Hello everyone, welcome to lecture 1 of CIN635. And in this lecture, we shall be looking at the introduction to mobile computing. Mobile computing, it is a computing environment of physical mobility, allows user of a mobile computing environment to be able to access data, information, or other logical objects from any device in any network while on the move. Mobile computing is a human-computer interaction in which a computer is expected to be transported during normal usage, which allows for the transmission of data, voice, and video. Mobile computing involves mobile communication, mobile hardware, and mobile software. Mobile computing allows users to perform a task from anywhere using a computing device in the public, that is the web, corporate, that is business information, and personal information spaces. For example, medical records, address books, etc. Mobile computing environment. Mobile computing is used in different contexts with different names. Mobile computing. This computing environment moves along with the user, similar to the telephone number of a GSM, global system for mobile communication phone, which moves with the phone. Anywhere, anytime information. This is the generic definition of ubiquity, where the information is available anywhere, all the time. A mobile computing environment involves accessing information through a wireless network connection. The mobile unit may be stationary, in motion, and or intermittently connected to a fixed or a wired network. Mobile computing environment continued. The second mobile computing environment that we shall be looking at is virtual home environment. It is defined as an environment in a foreign network such that the mobile users can experience the same computing experience as they have in their home or corporate computing environment. A virtual computing environment refers to a network-supported mobile computing environment that allows a user to access the same computing environment on the road as they would have at home or their place of business. The third computing environment is nomadic computing. This computing environment is nomadic and moves along with the mobile user. Nomadic computing is the use of mobile computing technology to connect to the global internet or use specific data resources from a stored location while moving around from one place to another. The next mobile computing environment is pervasive computing. It is a computing environment that is pervasive in nature and can be made available in any environment. Pervasive computing creates an unobtrusive environment with full and integrated internet connectivity. A combination of technologies is used to make pervasive computing possible, such as internet capabilities, voice recognition, networking, artificial intelligence, and wireless computing. The word pervasive means spreading widely throughout an area or a group of people. Next computing environment is ubiquitous computing, a every place computing environment. It is so much common that nobody even notices its presence. Ubiquitous computing environment is where computers are embedded in our natural movements and interactions with our environments. The next computing environment is global service portability. We also call it as GSP in abbreviated terms, making a service portable and available in every environment. Any service of any environment will be available globally. Global service portability makes service portable and available in every environment. Any service of any environment will be available globally. Wearable computers. can be worn by humans like a hat, shoe, or clothes. These are wearable accessories, needs additional attributes compared to standard mobile devices. Wearable computers are always on. It's operational while on the move, hands-free, context-aware. Context-aware comes from the different types of sensors found in those devices. Mobile computing functions. An environment can be defined as mobile if it supports one or more of the following characteristics. User mobility. User mobility is the ability of the user to move from one physical location to another and be able to use the same service. Network mobility. Network mobility is when the user is moving from one network to another and uses the same service seamlessly. Example, Wi-Fi network within the university campus and changing to 4G network outside when using the online service. Barrier mobility. The user is able to move from one barrier to another and use the same service. Example, a user is able to use the service through a web barrier at his home. When the user moves to an area where web is not supported, it switches over to the voice or SMS barrier to access the same application. What is a barrier? In telecommunications, barrier service or data service is a service that allows transmission of information signals between network interfaces. These services give the subscriber the capacity required to transmit appropriate signals between certain access points, that is, through user network interfaces. The next computing function that we shall be looking at is session mobility. Session mobility is when a user session must be able to move from one user agent environment to another. Example, a user is using his service through a data network, let's say from Vodafone Fiji via a mobile phone. When the user enters the basement to park the car, he gets disconnected from the network. He goes to his home office and starts using the desktop. The unfinished session in the mobile device moves from the mobile device and to the desktop computer. This is an example of session mobility. Next is agent mobility. Agent mobility is when the user agent or the applications should be able to move from one node to another. In computer science, nodes are devices or data points on a large network. Devices such as a PC, phone, or printer are considered as nodes. In a cloud computing paradigm, where applications will be moving from platform to platform and infrastructure to infrastructure, depending to temporal and economic considerations, there will be no fixed association between the application and the host running it. Software agents in the cloud will constantly be mobile. The next computing function is host mobility. Is when the user device can either be a client or a server. When it is a server or host, some of the complexities change. In case of host mobility, mobility of the IP address needs to be taken care of. A very good example is when smartphones are used as hotspot devices. When offering the service of a hotspot, the smartphone acts as a server. When the device is using the service of a hotspot, the smartphone is then considered as a client. Mobile computing segments continued. The mobile computing functions can be logically divided into the following major segments, and these segments are as such: user with device, networks and gateways, middleware framework, content, and data store. To start with, user with the device. It is a fixed device. Example, it can be a desktop, it can be a mobile device, it can be a digital TV, palm-top computers, laptops, etc. Network, whenever a user is mobile, he will use different networks at different locations at different times. Example, GSM, CDMA, Ethernet, wireless LAN, Bluetooth, etc. Gateway, this acts as an interface between different transport barriers. These gateways convert one specific transport barrier to another. Example, web gateway, SMS gateway. Middleware, This is more of a function rather than a separate visible node. It handles the security and rendering of the content on a particular device, or it can handle the security and personalization for different users. Content. This is a domain where the origin server and content is. This could be an application, system, or even an aggregation of systems. The word aggregation means a sum of. The content can be mass market, personal, or corporate content. The origin server will have some means of accessing the database and storage devices. Data store. This is basically the repository, the database that keeps hold of data and are used across all the other functions in the segment. Mobile computing devices can be either a computing device, example, desktop, laptop, or palm-top computer. Communication device, example, fixed line, telephone, mobile telephone, or digital TV. Usage of these devices are becoming more and more integrated into a task flow where fixed and mobile computing and communication functions are used together. The device is a combination of UE, user equipment hardware, plus UA, user agent software, which functions as an agent to connect the remote service, example, a web browser. Currently, there are 6 major types of mobile computing devices. We have laptops, notebooks, tablet computers, PDAs, smartphones, and portable data terminals. The first 3 which were mentioned, laptops, notebooks, and tablets, are called portable computers. The last 3 that were quoted, PDAs, smartphones, and portable data terminals, are often called as handheld computers. HCI, the abbreviation stands for human-computer interaction. It plays a critical role when computing technology is embedded into equipment for effectiveness, efficiency, and user experience. Mobile information and communication devices are becoming smaller and more restricted with respect to information presentation, data entry, and dialogue control. Human-computer interaction is a research in the design and use of computer technology, which focuses on the interfaces between people and computers. HCI, or human-computer interaction, observes the ways humans interact with computers and design technologies that allow humans to interact with computers in novel ways. Importance of HCI. HCI is a very important sector in computer science or in computer-based information systems. Every day we interact with several technologies having a basic application in our life. Sometimes it becomes difficult for us to understand the technology or device. Why it is important? User interface stands as an important element of any software. It is responsible for attracting the user of the application. Interaction or interface rather indicates an abstract model through which the humans interact with machines. Next importance, through HCI, one can gain an idea of user experience in which the computing devices and user application can be improved. Another notable importance is that HCI provides an interface which is designed to develop strong relationship between the device and the user, along with the services which the device has to offer and perform to achieve a task. HCI challenges: consistency in interaction between devices, appropriateness of interaction on a device or environment on which the system is being used. Does not have to be identical. Example, keyboard and mouse on a desktop and microphone and speakers on mobile phone. They are generally different from one another. Other challenges in HCI in relation to mobile computing may include small screen size. It tends to make input of data or text difficult. Next challenge is changing technology. It indulges in new types of interfaces every time there is an evolution of new technology. Next challenge, Designers of smartphones or mobile application developers do not have a standard guideline or methodology to follow when developing mobile phones. Therefore, sometimes the interfaces are inconsistent with the other applications or devices. Dialogue control. In any communication, there are two types of user dialogues: long session-oriented transactions and short session-less transactions. In long session-oriented transactions, it requires a series of steps to achieve an objective, often more than 2 steps. Example, when inquiring about your bank balance over the internet, the user first of all enters the URL of the bank site, then the account number or password, and log into the application. After that, the user selects the balance inquiry dialog and sees the balance. After seeing the balance, then the user logs out. You would notice that to achieve the objective, the user had to perform more than 2 steps. In short, sessionless transactions often requires short steps, 1 or 2 steps to achieve an objective. The same objective can be met through a single dialogue. Send SMS message, my bell, to the system and receive the information on balance. This is very similar to what we do normally with Vodafone services. What the user does, he or she enters or sends a blank message to 131 to get a message and to inquire about the balance of their SIM card. Networks, wireline or fixed line networks. Designed over wire or tangible conductors, example, fixed line telephone networks over copper and fiber optic, broadband networks over DSL rather, are public networks and cover wide areas. Although microwave or satellite networks don't use wires, but when a telephone network uses microwave or satellite as part of its long-haul transmission infrastructure, it is considered part of the wireline networks. Do note that the backbone of the internet or internet work is generally a wireline network. There are various advantages and disadvantages of using wired networks. Some of the common advantages may include: 1, stable and reliable connection; 2, faster speed and higher connectivity; 3, better security. Disadvantages of wired network may include: 1, inconvenient due to lack of mobility; 2, requires greater time frame for installation; 3, larger infrastructure requires greater maintenance; 4, messy and inconvenient due to many cables. Continuing on networks, now we should look at wireless networks, also known as mobile networks. This include wireless networks used by radio taxis, one-way or two-way pager, cellular phones, examples, personal cellular systems, AMPS, advanced mobile phone system, GSM, CDMA, and GPRS. With wireless networks also comes in certain advantages and disadvantages. Some advantages may include: 1, high mobility; 2, lower cost of setup; 3, bring your own device policy is often easy to implement; 4, overall look of office and workstation may be neat and organized; 5, easier to install and maintain. Some common disadvantages may include: 1, connectivity may suffer occasionally; 2, security can be a concern; 3, lower and unreliable data transfer speed. Ad hoc networks. In a small area network, especially with short-range wireless or temporary plug-in connections. In these networks, some of the devices are part of the network only for the duration of a communication session. New devices can be added to the network via Bluetooth or wireless LAN. 802.11. The best example of ad hoc networks is Wi-Fi setups at home. Barriers. For different types of networks, there are different types of transport barriers: TCP/IP, HTTP protocols for dial-up connection, SMS and USSD, unstructured supplementary service data, or web for GSM, voice for mobile or fixed phone. Network barriers may often mean in terms of SMS, MMS, GPRS, CSD, and USSD, and any other type of ways of communications or information are transmitted, communicated, or made accessible to persons via the networks from time to time. Middleware and gateways. Middleware is any software that is layered between a user application and an operating system. Some examples of middleware may include communication middleware, object-oriented middleware, message-oriented middleware, transaction processing middleware, database, RPC, etc. Middleware is a software that provides common services and capabilities to applications outside of what's offered by the operating system. In a mobile computing context, we need different types of middleware components and gateway at different layers of the architecture. So some of the different types of middlewares may include: 1. Communication middleware. The application communicates with different nodes and services through different communication middleware. Transaction processing middleware. In many cases, a service will offer session-oriented dialogues. However, the user may be using a device which demands a session-less dialogue made of short session-less transactions. In such cases, a separate middleware component will be required to convert a session-oriented dialogue to a session-less dialogue. Communication middleware is a computer software that enables two otherwise separate software components, processes, or applications to exchange information, either within one device or between multiple devices. Often, this is referred to as inter-process communication, or IPC. The next middleware that we shall look at is behavior management middleware. Different devices deliver and behave differently. Applications developed deliver in a certain manner. For example, we have one application for web, another for web, and a different one for SMS. On the contrary, we may choose to have a middleware which will manage device-specific rendering at runtime. This middleware will identify the device properly and handle all device-specific rendering independent of the application. The system may be required to have some context awareness, which will be handled by the behavior management middleware. This middleware, behavior middleware, will identify the device properly and handle all the behavior-related stuff dependent of the application. The system may be required to have some context awareness. All these will be handled by behavior management middleware. The term context-aware is the ability of a device or system component to gather information about its environment at any given time and adapt to its behavior accordingly. The next type of middleware is communication gateway. Between the device and the middleware, there is a system of networks. Gateways are deployed when there are different transport barriers or networks with dissimilar protocols. Communication gateway is a gateway device that can handle data transfer between host devices and slave devices. Example, controllers, instrumental devices, etc., without communication programs. Let's study this diagram and realize where the middleware and the communication gateways are located. If you'd have a look at the slide carefully, all servers and routers act either as middleware or gateway. The gateway is generally described through the use of the routers, and the servers generally act as both the middleware or gateways. Thank you for listening. This concludes for the lecture 1. I hope you had a good sense of learning in today's lecture, and we will wish you all the very best throughout the semester. Thank you.